All right, Precalc, we're working on Chapter 3, Section 1, and we are getting to exponential functions. So this is those logarithms that we did at the end of the year in Algebra 2. Chapter 3, Section 1, can you recognize, evaluate, and graph exponential functions? And I will say one of our weakest points is graphing these, so we're going to really try to do a little better on that. The exponential function f with base a is denoted by f of x equals a to the x, where a is greater than 0, a cannot equal 1, and x is any real number. So let's start to look at some of these. They're asking us just to use a calculator, and instead of putting in x, we're going to put in what's given. Why they wrote it like this, I have no clue. So this is literally just saying 8 to the pi power. And they're telling us to take a calculator, 8 to the power of pi, and to give an answer. 2.5, I'll round up to 5.5. So this one is saying 8 to the negative 1/2. 8 to the negative 1 divided by 2. And when I put this in my calculator, I get approximately 0.35. I will round up to 4. I guess I could have written them all out. And this one is saying 0.8 to the negative 2.5. And when I put that in my calculator, I get approximately 1.74. Let's round up to 7. Now, I would like you to explore these on your TI. We started to talk about exponentials, but remember, if I have anything to the 0 power, that's going to give me 1. Anything to the 0 power, that's going to give me 1. So when I graph this, I know that when x and y, when I plug in numbers, something is happening. So when I plug in 0, it's always going to go through 0, 1. But in this case, when I plug in 1, this one's going to go into 1 and 3. So the y has to be 3. But when I plug in negative 1, remember, a negative doesn't tell me to put it in the negatives. It's going to be positive 1/3. So a negative 1 is going to be like here. And remember, as we go deeper and deeper, it's going to get as close as you can to this x-axis, but it will never, ever, ever touch. So make sure when you're graphing it, you never show it touching the x-axis. And again, this is just the y. The only difference between the 3 and the 5 is that if I was to plug in numbers, when I plug in 0, it's going to go through 0, 1. But now when I plug in 1, it's going to go in through 5. And I kind of graph these the same. And this one's going to be a little steeper because that negative 1 is going to be positive 1/5. So this one's going to be a little bit of a steeper graph. So the question is, what happens when I have a 3 to a negative x and a 5 to a negative x? So if you want to push pause and explore on your TI, you can do that. And I know that still, when I have 0, it's still going to go through that 0, 1, and I'm going to graph these with the same amount of slots so you can see it here. But in this case, this one's going to go backwards. So when I plug in negative 1, it's going to go up to positive 3. And when I plot negative 1, it's going to go through that 1/3. So I'm going to draw this graph, and notice it just flip-flops over what we would call the y-axis. Again, it never touches the x. Now for the 5 to the negative x, when I graph negative 1, it's going to go through 5. And when I graph positive 1, it's going to go through 1/5. And again, never going to touch the x-axis. I do have a reminder here to look in page 181 and 182. Look at the library of parent functions and the exponential function. You should know all of your parent functions. Exponential functions are a little bit newer this year. We worked with them a little bit, but we're going to really dive in deep with them this year. So let's talk about what's happening to this graph. Right here, if I have on letter A, g of x is equal to 4 to the x minus 2, what's happening if I have that x minus 2 inside the exponent? All right, so remember that our parent function will always go through, whenever I plug in 0, so I'm going to graph this one first. Whenever I plug in 0, it's always going to go through 0, 1. And now when I plug in 1, it's going to go through 1, 4, and negative 1 is going to be 1/4. So this one in the blue is my parent function. But now they're asking us, well, what happens if I have an x minus 2? So whenever it's inside the exponent or underneath the radical or inside the parentheses, this is going to move left and right. So this 2 is actually going to move right 2 places. So from here, it's going to go right 2. And this 1 is going to go up here, and this negative 1 down here. So notice it just moves to the right 2 places, and it's almost exactly the same graph, except it moved. All right, what's going to happen? Well, let's look at this. What's going to happen with this one? Because we're still on that same parent function. Well, let's first look at the negative 1/2. I was going to switch to the q of x, but this one says negative 1/2 times 4 to the x power. So I'm going to actually put that in my calculator. Hopefully you are too. And I'm going to put negative 1/2 times 4 to the x power. And I want to see what happens here when I graph it. Notice this negative 1/2 is going to make it a little steeper. So my 4 to the x power is going to look the same. It's going to go through 0, 1, and 1, 4. And that's going to look like this. But now when I plug in numbers and I put in 0, now I have 0, negative 1/2. So I'm going to first make my little marks on my graph, but now I have 0 and negative 1/2. Well, that's going to be about here. When I plug in 1, negative 1/2 times 4 to the first is negative 2. So notice this one is just going to go a little steeper, has that stretch or that shrink. And probably without doing anything, you could tell me what's happening with this positive 3. So let's put this whole thing in our calculator. And again, we're just going to observe. I'm going to put in 4 to the negative x plus 3. So notice it's going to reflect over the y-axis, and in this case, it's going to go up 3.